Thank you for coming to another great presentation from the School of Architecture here at the Wilson campus. We have a formidable architect that has an incredible proposal for you to consider and to study. And again, welcome as students. I think you're going to have an unforgettable experience. I'm going to introduce an artist that has been with the college before, artist in residence at the North Campus, Lawrence Gartel, and he's going to be introducing our speaker this afternoon. Thank you for coming.
Thank you, Jose. Let me shut my phone first of all. Okay. So, first of all, Jose, I must tell you something. Next time I throw a party, I'm going to ask you to send out the Evites because you've got a great audience here. So thank you for making sure that all these people came. It's great. Now, because of that, he is standing in front of you. And I'll tell you something. I have never, ever, ever seen anything like it in my life. And he's a very humble man. I'm not so humble, to be honest with you. I would stand here and read my credits for, you know. And I know that Jose has things to do and you have things to do, so I'm going to move on with it. But I'll tell you something. This is just such an unbelievable person. And it is a privilege and an honor to know who Dr. David Fisher is. And it's really, you know, I'm proud to have been here at the college as an artist in residence. And I bring you Dr. David Fisher. David, thank you so much for being here.
Thank you, Robert. Thank you for that. It's a pleasure being here with you. It's not easy to start to speak about buildings after all these nice words, but I'll try to make my best. I would like to start with a short animation, if we can get it on.
Worked on the system.
Well, this is one question that I don't like to answer completely. But electricity is very easy, of course. It's called the bus system, like trains and machines. That's very easy. Besides the fact that in Germany they invented recently a transmission of electricity from distance. Something like from 4 inches you can transmit electricity. Water was much more complicated. And we considered to have containers on each floor and stop the rotation for a few minutes, fill the containers and continue. Nobody would fill it, of course. But I was not very happy. I wanted really to have continuous flow of water, like in a normal building, because the vertical piping is like in any normal building. The horizontal, like this building, like in any building.
So you keep talking about cost. I mean, I'd imagine it's very cheap to make it. So what's your market? Low-income families, middle class, high class?
I mean, the target for this building?
Yeah. Like, who are you working for?
Okay, the first buildings are going to be sold, of course, to people that have plenty of money. No doubt. We are considering it different, of course. In Miami, if we would build it in Miami, we were considering to sell apartments for between 1,200 to 1,500 a square foot, okay, which is quite high for today's situation in South Florida. In London, we consider to sell this apartment for £25,000, which is close to just over $3,500 a square foot.
Yeah, my question is on the core. Like, how is the core made, and how will it resist? How will it weather the time with all that rotating happening year in, year out?
Well, the core is based on existing technology. It's built with slip forms. It's a technology that was developed in the past for silos. Okay, and the slip forms goes up automatically in the project. So it came to be just perfect, or almost perfect, to put the elevators, the stairs, and so on, and all the MEP. So the core is about, in meters, about 30 meters diameter. This is what we need. And it sounds structurally better than any other structure, because again, here you have, say, dozens of columns. I bet that no engineer would know exactly the stress in each point of the structure, of the columns, of the beams, of the joint. And this is why most structures are over-designed. In a column like this, everything, the stresses are quite homogeneous. It's very easy to point maybe 95% of the stress at each point. So this is the core. It holds more than a normal structure. But something else, in case of earthquakes, this building, having one core, it's much more flexible. So it's the last one to break compared to a normal structure. And this is the core storage. On the floor, and the building is out, absolutely. And we had to make sure, because you cannot do such a building that is exposed to everybody and has any minimal risk. And even more so when you know that your clients are going to be these tycoons that spend maybe $30 million for an apartment, cannot take the risk that something doesn't work. So it seems to work. Yeah.
Hey, thank you, Dr. Fisher, for being with us, spending incredible time. And I want to ask you two questions. The first one is, what's your personal vision statement when it comes to this project? And the second one is, how do you want to be remembered for?
Okay. So the body doesn't feel it. As a matter of fact, some movement we are not aware of, but our body feels it. We feel uncomfortable, we don't know why, but the body does feel it. So we make sure that this vibration is much below the subconscious feeling of the body related to movement. And don't forget that we are in motion now. We are moving continuously, this way and this way. And I think that maybe, somehow we are more relaxed when we are in motion. When a baby cries, what do? You just put it in motion. Okay.
Yeah. Hurricane Interior and typhoons over there. They used to see that part of it.
Okay. Yeah, in Asia, I think they call it typhoon.
Yeah.
Right. So the building can shape itself to get the load of the wind much better. So if the wind blows here, the building maybe will rotate to have the best position against the wind load. While a normal building has to fight the wind,
Exactly,
I can.
It's a stationary.
By the way,